So now joining us to talk about the earthquake in Japan is UConn Professor of Physics, Vernon Cormier. Good to see you. Thanks so much for coming in, Professor. So we were talking earlier that you can't really predict exactly when an earthquake is going to strike, but you can use some science to determine the probability of about when it might and where it might hit?
That's right. We can do something like a forecast, much like a weather forecast, a certain probability of a certain size earthquake in a certain place in a certain time interval.
Was anything forecasted for Japan for this particular earthquake?
There probably was. I haven't followed the details, but the earthquake distribution is well followed in Japan. It's along a major plate boundary, and by looking at the past history of distribution of earthquakes and a gap where earthquakes should happen but haven't happened in some time period, you could predict or at least forecast the greater probability in that area of a large event.
Can you forecast what the magnitude is going to be?
You can sometimes forecast that well, yes. If you see what we call a seismic gap, the Japanese actually invented this called the Mogi donut, a rim of the donut having earthquakes and the donut hole not having earthquakes. The hole will be the probable place of an earthquake. It will fill that hole, and the size of the hole will be like equal to the magnitude.
Japan has a lot of earthquakes, and they're actually probably the best prepared for earthquakes. Talk a little bit about that.
Yes, they're very well prepared. They've had a spectacular history of disastrous earthquakes. Tokyo, 1923, literally wiped out the city. So they're well prepared, as any place on earth can be prepared, designing buildings and mobilizing people to be prepared for an earthquake.
It's like a double punch. You have the earthquake, which has now been upgraded to a 9.0, and then that earthquake sets off the tsunami, which we've seen the video and we're looking at it now, that huge wave of water that just comes cascading over into the land. Talk about how the earthquake causes the tsunami and how much time you have in order to get away from the impending tsunami.
Well, in the case of Japan, the tsunami was generated by a so-called subduction zone earthquake. My left hand is Japan, my right hand is the Pacific plate. It's sliding underneath Japan. What happens at the fault, it gets stuck in the fault zone, are glued together, and it snaps and goes under, and the snapping action up of the earthquake is much like your hands in a bathtub, raising some water, which generates the tsunami.
How fast does that wave travel?
Tsunamis travel sort of on the order of a jetliner, about 500 miles an hour, which is fortunate because that enables us to predict tsunamis. Once we've located the earthquake and estimated its size, we can predict the arrival of tsunami in different places.
Do we have to be concerned here in Connecticut and the East Coast about earthquakes like this?
Not like this. New England can have earthquakes. Generally, we'll have something on the order of a magnitude 3 every 10 years or so, and some felt reports every year. But we're not on a major plate boundary as Japan. We're very far away from a plate boundary, one on the west coast of the U.S., the other in the mid-Atlantic ridge. So our probability of strong ground shaking is much lower in New England.
Professor Vernon Cormier, thanks for coming in.
Thank you.
We appreciate your time.